Hi, so let's talk about some important wireless terms now. The first one is an access point. An access point is a device which radiates wireless signals so that the client can join the wireless network. These access points are also responsible for converting the wireless frames into Ethernet frames and vice versa. We can also say that these access points also works as a translational bridge where frames from two different medias are converted or translated and bridged at layer 2. Let's make a block diagram here to understand how this AP works. So let's say if this is an AP and these are the two antennas of this AP. And AP can have two antennas or four antennas based on the model of the AP. And these APs also do have an Ethernet port which connects with the switch. And if this switch is a PoE switch, that means power over Ethernet switch, this switch gives the power to this AP. And let's say if this switch is not a PoE switch, then what will happen is we will connect an external power injector with this AP, which will give power to this AP. APs can have multiple Ethernet ports based on the model. So let's say if this Ethernet port is Ethernet 0, then the second Ethernet port will be known as Ethernet 1. These Ethernet ports do have a MAC address. When we connect the AP with the switch, we learn this MAC address on this interface of the switch. Or when we see the CDP neighbor or the LLDP neighbor, we find out this Ethernet port number is connected on this port and this is the MAC address which we learn on that interface. And if let's say this AP is getting an IP address, which is the management IP of the AP, we can see that IP as well on the CDP neighbor of this switch or on the LLDP neighbor of this switch. APs do also have the radios. These radios are the one which generates the RF energy. So let's say this is the model of the AP which supports both the bands. So it will have 2.4 gigahertz radio and 5 gigahertz radio as well. APs broadcast the wireless signals. And let's say if there's a client which is in the range of this AP, this client will join in this AP. Okay, let's say if this is client 1, so this client 1 will join this AP. Of course, all the authentication and association processes should be completed before this client joins this AP. The second term is wireless controller. Wireless controller is the one which manage and control multiple APs, which is actually the brain of the wireless infrastructure. And in wireless controller, we push the wireless policies and all the required configuration are done on this wireless controller only. So we can also push policies and install certificates on this wireless controller. And all the important configuration are done only on this wireless controller. As we already said, yes, it is the brain of the wireless infrastructure. So where it connects in this diagram. So in this diagram, the wireless controller will be connected with the switch. Okay. And most probably this port is configured as a trunk port so that all the required VLAN can be passed through this trunk port. Based on the model of the wireless controller, multiple APs can connect with this wireless controller. The third important term is BSS, which is known as basic service set. It is actually the coverage area of a PC, or we can say of a client. So what happens is, like an access point, these clients also generates RF power and they also form their own coverage area. So this coverage area is known as BSS. So whatever the wireless device will connect in this coverage area, this client can join that wireless client. The next one is BSA. BSA stands for basic service area. It is the coverage area of an AP. We also call it as a cell, or we can also call it as a range. So in this diagram, if you will see, this will be the coverage area of this AP. And this will also be known as a cell or a range or a BSA. Sometimes in wireless infrastructure, BSS and BSA are interchanged with each other. Now let's talk about SSID. SSID stands for Service Set Identifier. Actually, SSID is the name of wireless network or the name of wireless LAN, wireless local area network. So what actually is wireless local area network? Before we discuss about wireless local area network, let's discuss about what LAN is. LAN stands for local area network. So what happens when one or more than one client connects with each other through some networking device, they form a network. So this will be a network. And because these devices are connected locally, or these clients are connected locally, this will be called as local area network. So what will happen if I will connect few more devices here? This network can become very large and it will be very hard to manage this network. So what we do is, we divide this big network into small parts. And how we divide that? We divide it by using VLAN. So what happens is, we give a VLAN a particular number. Let's say this VLAN has a number 10 and this VLAN has number 5. So all the devices which are in VLAN 5 will become a separate network or a virtual network, or all the devices which are in VLAN 10 will form a separate network. So now at this point, both these VLAN 10 and VLAN 5 are different networks. The device from VLAN 5 cannot communicate directly with device of VLAN 10 unless we do some kind of inter-VLAN routing. Now let's try to understand what WLAN is. WLAN stands for wireless local area network. So in the same picture, remove this wired connection with some kind of wireless connectivity and replace this switch with an AP. So it will look something like this. Client 1, client 2 and client 3. Okay, client 1, client 2, client 3. And in place of a switch, they will connect with an AP. And how they will connect is through some wireless medium. Now all these devices are connected with this AP. This network will be known as wireless local area network. And similarly, we can also break this wireless local area network into smaller multiple wireless local area networks. And how we do that? We do it again with the use of a VLAN. And how we do this is, we assign this VLAN to a particular WLAN. And let's say the name of that WLAN is guest. And this name is known as SSID. And as we saw in the definition, SSID is the name of the wireless local area network. So similarly, the access point can also broadcast multiple wireless local area network, or we can say multiple SSIDs. So let's say the name of the first SSID was guest, and this can broadcast another SSID to which clients can connect, let's say client 4 or client 5. And the name of the second SSID would be employee. So in common English, what we can say is SSID is the name of the wireless local area network to which wireless clients connects. So there are few things which are required when we configure an SSID. The first one is the name of the SSID. So in this case, we named this SSID as guest and we named an SSID as employee as well. The second one is VLAN. So this is the same VLAN which we discussed here. So the client which will connect with these SSIDs will get the IP address from this VLAN. The third one is the encryption type. That is, what kind of encryption will be used by this SSID. We can have WPA version 1, WPA version 2. We will discuss more about these encryption types in upcoming slides. And the fourth one is the authentication type. This will tell what kind of authentication this SSID will use. So let's say if a client wants to connect with this SSID, so what kind of authentication mechanism will be used? Whether it will use open authentication or a .1x authentication or a pre-shared key-based authentication. And the final is radio bands. These are 2.4 gig and 5 gig. So this will tell in which RF band this SSID will be broadcasted. So let's say user wants to broadcast one SSID in only 5 GHz band, not in 2.4 GHz band. Or maybe user wants to broadcast particular SSID in 2.4 GHz band, not in 5 GHz band. That entirely depends on the network type.